Miss Jackson coming to you with another video.
Okay, now we're going to look at the graph of y equals 1/2 sine x. Alright, again, my parent graph is y equals sine x. So this would be a transformation of my original parent graph. Alright, so in this function, my a is 1/2. And I know that my amplitude is going to be the absolute value of 1/2, which is just 1/2. All right, and I know that my absolute value of 1/2 is actually less than 1. So my graph will experience a vertical shrink. All right, my b is 1. That's the coefficient in front of the x. My period is 2 pi over the absolute value of 1. And that is 2 pi divided by 1, which is just 2 pi. So again, my period is the same as my parent graph, so the angles are going to be the same. Okay, so I have my graph drawn, and I have my angles plotted: 0 pi over 2 pi, 3 pi over 2, and 2 pi. So I'm going to create my t-table and put those angles on my t-table. My function is 1/2 sine of x. All right, so I have 0 pi over 2 pi, 3 pi over 2, and 2 pi. So again, if I plug these into my function, I have 1/2 times the sine of 0. I have 1/2 times the sine of pi over 2. I have 1/2 times the sine of pi. I have 1/2 times the sine of 3 pi over 2. And then 1/2 times the sine of 2 pi. So again, if I look at the unit circle for the sine of 0 pi over 2 pi, 3 pi over 2, and 2 pi, I'm going to get the sine of 0 is 0. And 0 times 1/2 is 0. The sine of pi over 2 is 1. And 1 times 1/2 is 1/2. The sine of pi is 0, so 1/2 times 0 is 0. The sine of 3 pi over 2 is -1, so 1/2 times -1 is equal to -1/2. And the sine of 2 pi is 0, and 0 times 1/2 is 0. So I'm going to have a point at 0, 0. I'm going to have a point at pi over 2 1/2. I'm going to have a point at pi 0. I'm going to have a point at 3 pi over 2 -1/2. And I'm going to have a point at 2 pi 0. All right, so you can see that my graph is a vertical shrink. So the amplitude is 1/2, where for my y equals sine x graph, my parent graph, the amplitude would be 1. So you can see that it shrinks vertically. Okay?